Welcome to the Explainer. We're jumping right into something absolutely crucial today, the CI/CD pipeline, and a little, incredibly powerful tool known as Jenkins. Whether you're a seasoned tech pro or just getting your feet wet with coding, we're going to break down exactly how modern software actually gets made, tested, and delivered. Let's get to it. So think about this for a second. How is building a massive software application like cooking a really complex dish? Let's say a rich, delicious Shahi paneer. Sounds like a weird comparison, right? But stick with me here. Both of these require a very specific set of ingredients, and both need steps done in a precise order. If you mess up early on, the whole thing is a disaster. We're going to use this cooking analogy to demystify what software engineers are actually doing all day. To really get why the CI/CD pipeline is such a game changer, we have to look back at the dark ages of software development. In the old days, a developer might write, 50,000 lines of code over days or even weeks. Then they'd toss that massive chunk of code over to a testing team, who might take another 7 days just to find a single error. Now, with a CI/CD pipeline, a developer writes just 50 lines of code, pushes it, and boom, it's tested automatically in 5 minutes. You really have to understand the human cost of that old method. Imagine coding for 3 straight days, moving on to a totally different project, and then a whole week later, a tester taps you on the shoulder and says, "Yeah, your code from last week, it's broken." Finding a missing comma or some tiny logic error in 50,000 lines of code is a literal nightmare. Your brain has to completely switch context back to what you were thinking 7 days ago. It's wildly frustrating and just wastes so much time. And that's exactly where the concept of a pipeline swoops in to save the day. Let's go back to our Shahi paneer. When you cook, you follow a sequence. Step 1, buy the ingredients. Step 2, wash them. Step 3, chop them. Step 4, cook. You can't chop the veggies before you buy them, right? And you definitely shouldn't cook them before washing them. These tasks absolutely must happen sequentially to get a good result. That strict step-by-step sequence perfectly illustrates a core technical concept called first in, first out, or FIFO. Think of a physical pipe. If you shove a ball into it, followed by a pen, and then a toy bicycle, well, they're going to come out the other end in that exact same order. The first thing in is the first thing out. Software pipelines work the exact same way. Code flows through a very strict, automated sequence of events. Which brings us to the CI in CI/CD, continuous integration. In our kitchen analogy, continuous integration is like tasting your ingredients as you prep them. Instead of waiting until the whole meal is cooked to realize your tomatoes went bad, you're testing small chunks of your work constantly. In software, developers continuously merge their tiny 50-line updates into a central system, and that system automatically builds and tests it right then and there. The most mind-blowing difference here is the time saved. The old way meant waiting a full week to find a bug. But with a CI/CD pipeline, you find it in 5 minutes. Because the developer just wrote those 50 lines of code 5 minutes ago, the logic is totally fresh in their mind. They know exactly where they messed up, they fix it immediately, and they move on. This automation is absolutely crucial because it stops bugs from compounding early in the development lifecycle. Okay, let's step out of the kitchen and back into the computer lab. Our actual software pipeline sequence looks like this. Step 1 is code. The developer writes the logic. Step 2 is build, compiling that code into a working file. Step 3 is test, running automated checks to squash any bugs. And step 4 is deploy, sending that finished bug-free code out into the real world. It's a strict sequential flow, just like buying, washing, chopping, and cooking. So let's put some real-world names to these stations in our software kitchen. Usually, developers store their code in GitHub. Then, that code is built into a runnable program by a tool like Maven. After that, it gets rigorously tested for errors by something like Selenium. And finally, the finished product gets deployed to servers by configuration management tools like Chef or Puppet. Now, we talked about continuous integration, but what about the CD part? Well, CD actually stands for 2 different things depending on your setup. Continuous delivery is basically cooking the food, putting it in a takeout box, and handing it to the customer. You give them the ready-to-install file, and they install it themselves. Continuous deployment, on the other hand, is like cooking the food, plating it beautifully, and serving it right to their table. The software is automatically installed and launched directly onto the client's live servers. But hold on, here is the multi-million-dollar question. You've got GitHub, Maven, Selenium, Puppet. They're all totally separate tools made by different people. So who exactly is coordinating all of this? How do we actually get these tools to seamlessly talk to each other without some poor human sitting there constantly clicking download, build, test, and deploy every single time a line of code is written? The answer to that? Jenkins. As our source material lays it out perfectly, Jenkins is an integration tool. It is literally the glue holding the entire CI/CD pipeline together. Jenkins sits smack in the middle of the software development lifecycle. It doesn't write the code itself, it doesn't build it, it doesn't test it. Instead, it connects all the separate tools that do. Think of Jenkins as the ultimate restaurant waiter. Imagine a high-end restaurant with a brilliant chef, top-tier ingredients, hungry customers, but zero waiters. The kitchen would just grind to a halt. Jenkins is that tireless, automated waiter constantly running back and forth, making absolutely sure every single station gets exactly what it needs, the exact moment it needs it. Let's walk through a shift with our waiter, shall we? Jenkins is constantly keeping an eye on GitHub. The moment a developer pushes new code, Jenkins takes that order. It automatically carries the code over to Maven, our chef, to be built. Once Maven is done cooking, Jenkins grabs that built file and runs it over to Selenium, our taste tester, for automated testing. If it passes, Jenkins finally serves it up to the deployment tools for the customer. The whole shebang happens without a human lifting a finger. You know, the history of how Jenkins became the industry standard is actually pretty fascinating. Originally, there was a project called Hudson, created by Sun Microsystems. But when Oracle bought Sun, they basically split the project. Oracle kept Hudson as a paid enterprise tool. Meanwhile, the community branched off and created Jenkins as a completely free, open-source tool. And because it was free, the global tech community rallied behind it, wrote thousands of editions for it, and made it the absolute king of the industry, leaving the paid Hudson totally in the dust. A few quick, essential facts about Jenkins for you. First, it's written in Java, so you gotta have Java installed to run it. But because it's web-based, it runs beautifully on Windows, Mac, or Linux. Like we just talked about, its open-source nature gives it incredibly powerful community support. But its true superpower, the thing that really makes it tick, lies in its architecture, which relies super heavily on things called plugins. So how does Jenkins actually connect all these different tools? Plugins. Think of them like the USB ports on your laptop. Your laptop doesn't natively know how to be a mouse or a pair of headphones, right? But if you plug a mouse into the USB port, they communicate perfectly. Plugins are Jenkins USB ports. There's a plugin for GitHub, one for Maven, one for Selenium. You simply plug them in and suddenly Jenkins knows exactly how to talk to these external systems. Handling scale is where Jenkins really flexes its muscles. If you're a massive company, your pipeline might be processing thousands of code changes a day. A single Jenkins server would just get crushed. To fix this, Jenkins uses a master, slave, or masternode architecture. You have one central Jenkins master barking out the orders, and you attach multiple worker nodes to it. The master takes a massive workload, chops it up into tiny tasks, and distributes them to the workers so everything gets done lightning fast. This source material actually wraps up with a beautifully poetic ghazal, which is a form of Arabic poetry. And honestly, it hits the nail on the head. Writing a ghazal, just like writing code, is an act of continuous creation, testing, and revision. You write a line, you test how it sounds, you fix the rhythm, and you build it sequentially. The CI/CD pipeline essentially takes the messy human art of creation and gives it a highly efficient, automated structure. That way, errors are caught super early, and the final product is flawless. We've seen how transforming a manual, weeks-long nightmare into a smooth, automated, 5-minute sequence literally changes everything for developers. Automation prevents bugs, saves a ton of time, and keeps the creative flow going. So I want to leave you with this thought. If Jenkins was the ultimate waiter for your daily life, seamlessly connecting all your tools and tasks in the background, what manual process would you automate first? Think about it. Thanks for hanging out with me on The Explainer today, and keep learning.